Hello friends, so here we'll be solving some questions on equations of motion. So we'll start with simple questions and then we'll move to a bit more difficult ones, okay. So this is the first question and it is given that a body starts from rest and acquires a velocity of 12 meter per second in 5 seconds, and we have to calculate the acceleration of the object and the distance it has traveled in those 5 seconds. So first, what you have to do while solving any question, first you have to note down the data which is given. So for this, it is given first, it has been given that it is starting from rest. The object is starting from rest. So here initial velocity, initial velocity u is equal to 0 meters per second. The rest, it's starting from rest, and acquires a velocity of 12 meter per second in 5 seconds. So 12 meter per second is the final velocity. It is the final velocity v, which is equal to 12 meter per second. That is the final velocity. Time taken is equal to 5 seconds, which is equal to t. It has been asked to find the acceleration a. So we have to find a formula, equation of motion, which relates final velocity, initial velocity, time and acceleration. So if you remember the equations of motion, the 4 standard equation of motion, then the first equation of motion which we derived, which is final velocity is equal to initial velocity plus product of acceleration and time. This can be used here. This can be used where acceleration is equal to v minus u by t. This. So here it is equal to, if we put these values, we will get v is equal to 12 meter per second, initial velocity u is equal to 0 meter per second, time is equal to 5 seconds. So it is 12 by 5, which is equal to 2.4 meters per second square. That is the acceleration. Acceleration is equal to 2.4 meters per second square. This. Then the next thing which is asked is the displacement of the object, or the distance it has traveled. It is traveling in straight line, so distance, displacement is the same thing. So here it is s, it has been asked. So again we have to find a formula that relates all these parameters: initial velocity, final velocity, time, acceleration, all that. So here we have s is equal to ut plus half at square. This formula, you remember, we derived the second equation of motion. So here if we put the values, s is equal to ut, u is 0 into 5 plus half, a is here 2.4 acceleration, t is equal to 5 square. This becomes 0 and this is equal to, it is coming around 1/2 at square, that is equal to, yes, it is coming around 30 meters. So the distance, the displacement in those 5 seconds, that is equal to 30 meters. Okay, there is also another way in which we can determine this. If you remember the third equation of motion, not the third one, this one, okay, v square minus u square is equal to 2as. If we use this formula here, this equation of motion, then if we substitute the values, final velocity is 0, initial velocity is final velocity is 12, initial velocity is 0, here it is 12 square minus 0 square is equal to 2 into acceleration is 2.4 into s. That implies s is equal to 12 square by how much? 4.8, 2 into 2.4. So that is coming around, let us yes, 30. It is coming around 30 meters. Okay, so here also the distance or displacement, that is equal to 30 meters. So in both ways, whichever formula you use, whether you use v square minus u square is equal to 2as or s is equal to ut plus half at square, you are going to get the same result. Okay, you are going to get the same result. So here a very basic question. First we noted down the data which is given, then using the standard equations of motion, depending upon the requirement and the data which is given, which formula to apply where, we decided. So then we applied the first equation, v equals to u plus at, to determine the acceleration, and then we had two options, whether to use s is equal to ut plus half at square, that formula, or v square minus u square is equal to 2as to determine the distance travelled. Okay. So here is another question. So it is given that when the engine of an electric train 72 meter long, it passes a stationary car, its speed is 6 meter per second, and when the tail end of the train passes the same car, its speed is 9 meter per second. What is the acceleration of the train and what time does it take to pass the car? Okay, so first let us understand. So here first we have is a car which is there on the road. Okay, there is a car. A train is passing by, and when the head or the starting end of the train is approaching the car, at that time, okay, let's say this is the train, its length is 72 meters. Okay, its length is 72 meters. This is the head or the beginning end, and this is the tail end. So here at that time when it is passing, its velocity is how much? 6 meters per second. And when it has passed, already it has passed, okay, when it is, the tail end is there, okay, when the tail end is just past the car, at that time its velocity is how much? 9 meter per second. So here the important thing to understand is that this train is passing the car which is the reference point here. This here 6 meter per second, which is said that when the engine of the train or the head end or the starting end of the train is approaching or has just passed the car, that is the initial velocity. That is the initial velocity u. And when it has completely passed the car, the entire length of the train has completely passed the car and there is the tail end is there, at that time the velocity is final velocity. Okay, final velocity v. And this 72 meters which the train has covered from the head end to the tail end to completely pass the car, that is the distance it has travelled, 72 meters. Distance or displacement, whatever you want to call it, because it is travelling in straight line, that is displacement. Now it has been asked to find the acceleration and the time. So here we have to find a formula which involves the final velocity, initial velocity, acceleration and displacement or distance. So we have v square minus u square is equal to 2as. Final velocity whole square minus initial velocity whole square is equal to 2as, acceleration and displacement. So here final velocity is 9, so 9 square minus initial velocity is 6 and 6 square is equal to 2 into a is we have to determine, s is 72 meters. So here that implies a is equal to 9 square minus 6 square by 2 into 72, and that is equal to 81 minus 36 by 2 into 72, which is equal to 45 by 2 into 72. So that is coming around 0.3125 meters per second square. Okay, that. Then we have been asked to find the time it takes. Okay, so this is the acceleration. A is equal to 0.3125 meters per second square. Time. So in order to determine the time, here we have a formula, v is equal to u plus at. Final velocity is equal to initial velocity plus at. So here final velocity is 9, initial velocity is 6, acceleration is 0.3125 into t, which we have to determine. So t is equal to 9 minus 6 by 0.3125, and that is coming around, it is coming around 9.6 seconds. Okay, the time is 9.6 seconds. Okay, so these are the two parameters that we wanted to calculate. So again, this question is a bit different, it is directly, the data is not given. Here you have to use your common sense to determine, okay, it has been given that when the head of the train or the starting point of the train is approaching the car which is stationary, at that time the velocity is this much. So we are talking about initial velocity. When the tail end has completely passed the car, at that time the velocity is 9 meter per second. So that is the final velocity. The entire length of the train which has passed the car, that is the distance or displacement. From that we have to use appropriate equation of motion to determine the required parameters which is asked. Okay, so this is the solution.